Wow. Wow. Ah. Bonjour tout le monde, comment ça va? Ouais, toujours bien. Hein? Cette vidéo contenait de meilleurs effets que Marvel. Vous l'avez vu? C'est incroyable. Allez, je vais donner mon talk en anglais, mais je voulais juste l'ouvrir en français, juste pour vous faire plus confortable. Alors, j'ai une demande. Je peux vous poser, on peut prendre une photo ensemble, s'il vous plaît? OK. Je vais le faire comme ça, OK? Pretend to be happy, OK? Just, OK. Ouais, boom! Open source! Woo! Merci beaucoup à tout le monde. Je vais le montrer à ma fille et je vais lui expliquer. Voici eux, ils m'écoutent. Incroyable. Allez, my friends, I'm so happy to be here. I am so happy to be here. It's the first time since that terrible pandemic. Quel cauchemar. My name is Josh Long. I work on the Spring team. I'm a Kotlin Google developer expert, a Java champion, and a Spring developer advocate on the Spring team at VMware. And most importantly, I am at your service, okay? So if you have questions, anything I can do to help, please find me on the internet. I have a YouTube channel. It's okay. It's not, it'll get better. But anyway, there's lots of ways to find me on the internet. My friends, we're going to talk about Spring Boot 3 today. Spring Boot 3 is very exciting for me because it represents a huge new opportunity for developers. We released Spring Boot 3 last Thanksgiving. Thanksgiving is a holiday in the United States. It's a day where we take the day off. And that's easy for me to remember. Thanksgiving, Spring Boot 3. It's the most important release of Spring Boot since Spring Boot 1.0, which we released on April Fool's 2014, right? Poisson d'Avril, the same holiday, right? We released it on that date, 2014, 8 years ago, or 9 years ago, right? So very, very big release, lots of new changes. And so I want to talk to you about that stuff. And so as always, we're going to do so by writing some code so that we can kind of explore the possibilities. Now, my friends, we want to write production-worthy code. That's the important thing here, right? I want to write code that is worthy of production. And so, as always, I will start my journey here at start.spring.io. Good. So, we're going to build a new software, okay? We have some choices here. First of all, the default is now Gradle. Have you noticed this? So if you go to start.spring.io, it's Gradle. You can choose Kotlin or Groovy or Maven. All of them are fine. I don't care. Any language you like, it's great. All of them are fine. I'm just going to use the defaults. We have the choice of what name to give our service. I'm going to use the word service for my service. It's because I'm very good with names. I'm like my father. My father, we had a little tiny white dog when I was a child, and my father named him White Dog. and then that, je plaisante pas, truly, je le jure. And then that dog disappeared. After like 10 years, that dog disappeared. We don't know, maybe he went to a farm upstate, I don't know. Anyway, another white dog appeared. And then my dad, he named that one Two. So yeah, I'm just going to call this service. It works fine. Then, my friends, we have the choice of what version of Java we would like to use. Friends, we have a few choices over here that are non-choices. You should never make these choices, ever. You could make these choices, but you should not. Java 17 is the new baseline for Spring Boot 3, so you must use Java 17 or later. Javas 11 and 8 are not appropriate choices in any context except when you want to show people what not to do, okay? Java 8 and 11 are old, technically inferior in every way. They are slower, they have less syntax, less performance, less readiness for production, for containers. They are technically inferior in every way. They're also morally inferior in every way. You won't like the look of sadness and fear in your children's eyes when they see that you're using Java 8 in production. Don't do it. Be the change you want to see in the world. Do the right thing. Use at least Java 17. And consider the timeline. Remember, this is a new generation of Spring, Spring Framework 6. We released Spring Framework 5 more than 5 years ago. So I don't have the ability to see the future, but imagine another 5 years will go from Spring Framework 6 and then maybe 5 years into the future. We'll have Java 29 maybe, or Java 30, right? That's a long time, and it'll be supported against Spring Framework 6, the entire 17 all the way to like 29 or something like that. So Java 17 is the minimum, but really you should probably be using Java 20. Java 21 is almost here. That's going to have Project Loom. There's really great stuff in Java. It's up to us to move forward. All right, my friends, we're going to bring in some dependencies. We're going to bring in H2. We're going to bring in JDBC. We're going to bring in the web support. We're going to bring in GraalVM-native image support. And we will bring in the Spring Boot actuator. I'm satisfied with those choices, so I'll go ahead and generate a zip file. And I'll open this in my IDE. It doesn't matter what IDE you use, but I am very curious. How many of you are using IntelliJ? Wow, la plupart. C'est la plupart, mais pas tout. OK, Visual Studio Code. OK, Inertiert, OK. Eclipse. Oh, ce sont les mêmes? OK. Either way, very cool. I love our community. OK. So we are going to build a new application. Can you all see? Oh, yeah, of course. C'est plus grand qu'un édifice. OK. Comme ça, OK. Yeah. So we're going to build an application to talk to a database. I will use a nice feature from a new version of Java, and I love this. I love this so much, right? I love this ability to create a record, right? Just, oh, so good, so good. So we're going to create a repository, and it's going to extend the CRUD repository. Actually, we're going to do a service. Let's just do a service. We'll do it the old-fashioned way. And here I'm going to create some endpoints, some methods to deal with data from our database, OK? So we'll have one that returns all the data, and then one that returns the data by name, like this, OK? And of course, in order to make this work, we'll turn this into a Spring Bean. We're going to use the auto-configured JDBC template like this, OK? Enter that. Good. And we will say return this .template.query, select all from customer. And we will need a pointer. We're going to use a row mapper here. This is a very old API in Spring. It's just very old, but it works really well even today, right? So new customer, rs.getID, rs.getStringName, OK? Very simple. Look at that. And we can just reuse that here. And then do the same thing. Let's see, query for list, maybe? C'est ça? No, just query. OK, good. Query, and then do the same thing down here, basically the same thing, okay? Except we're going to pass in the name, and we're going to say select all from customer, where name equals question mark. Good. So now we need to actually have a database, and I'll tell Spring to initialize one. This is not new. You could do this before, of course. I just want to take advantage of this. So we're going to create a table called customer, ID, serial, primary key, name, var, car, 255, not null, null, okay? Very good. And then we have some data. And here, my friends, I need your help. I need some help here. Let's put some people into the database. I'm going to need some names, obviously. So my name is Josh. It's so very nice to meet you. Plaisir, enchanté, tout ça. OK. The rest of you, I need some other names. Who wants to be my first volunteer? Volunteer. You, my friend. Tim. OK, yeah. Like comme ça? Tim. C'est tout? I was expecting some very nice French name with 10 vowels, you know. It's great. Nice to meet you. Anybody? Stefan. Is it like comme collègue? Like comme ça? No? F? C'est pas ça? Huh? Oh, off. OK, sorry. Eh? Oh, this one. Oh, different one. I'm looking at a different person. It's OK. Hi, Stefan. How you doing, buddy? Good to see you. OK. Let's see. We need some more victims. Oh, yeah. There we go. I got one. There. That's 4. That's a nice round number. Very simple. It's let's just move on. I'm happy with those numbers. Very good. We've got our data in the database. Let's just create a bean that will get initialized when the application starts up. OK. So application runner. And here we're just going to return some data, okay? So we'll have customer service, and we'll say service.all.forEach, and I'll just print these out as I see them, okay? Just to confirm that everything is working as we expect, all right? So very good. Let's restart this. Restart the application. Why doesn't it? Let's see. Run this. Very good. Okay. Compiling. There you go. Good. So there's our data. It worked. Of course it worked. It was a demo. It was always going to work. There's no question there. No question. So what I wanted to do is, we've got the data there, but I also want to create an HTTP endpoint. So I'll create a REST controller here, like so, class customer HTTP controller. Very good. And here I'll inject my customer service, right? Service, like this. We're going to inject that into the constructor. Very good. And we'll say get mapping customers, collection of customer, all. And I'm just going to delegate to that service that we just created. Pretty straightforward, right? Not a big deal here. Let's see if that works. So name, and we can just delegate here as well to that path variable, right? String name, and we say by name, name. Very good. Okay, we're going to run this and see if that works. Okay, so we go to the browser, customers, hello. Okay, there's that. Name, Josh. It's worked. It's not very production-worthy code, but it does work. Now, let's talk about turning this into production-worthy code. The first thing is, I want to introduce validation, okay? So let's suppose that I have an assertion. I say, okay, the name at the beginning has to be capital letters, okay? And so the name must start with a capital letter, like that, okay? Good. Well, what happens if this is incorrect? What happens if I throw that exception? Well, I'll get an illegal state exception. And so what I want to do is I want to centralize that error handling, and a very natural way to centralize that error handling is to use error handling controller advice, okay? And here I can create an exception handler, public response entity or something like this that returns handle. It returns a response when we get a certain type of exception. Now, friends, I could use Spring Framework's default error handling, and that would give me a representation of the error, but it would do so that's in a way that's unique to Spring Boot. And I've heard, I have not seen yet, but somebody told me something very terrifying. They said there might be people who are not using Spring to build software in production. Apparently, this is a possibility, like the Higgs boson particle, right, years ago. It's scientifically provable, we just haven't seen it. But if this happens, then I want to have a standard representations for the errors. And to that end, there's a problem details RFC 7807. This is a standard way of representing errors in HTTP APIs. And there's now new support for that here. So I say problem details enabled equals true, and then I can return a problem details object, okay? So I'm going to say like this, problem detail dot for status, and whatever error code you want, bad request dot value, pd dot set details, e dot get localized message, return pd dot, there you go, that's it, right? Maybe I don't want the localized message. I don't even know if I have one. Get message, okay? So let's see what that does for us, okay? We'll run this again. Command line, curl, HTTP, localhost, 8080 customers. Now, remember, lowercase, okay? Very important. There you go. So if I do that, I get an error, and that's a problem details response. Small, but nice, okay? Small thing in Spring Framework 6. Another thing that I want is I want to make it so that if I have an exception, I can kind of see what's happening in the request. And one way to do that is to inject the current request. Now, I could do all sorts of interesting things here. I could just get the headers or something like that. I don't know. You could think of something here. Not too hard to imagine what you could do. But what's interesting about this is not the header so much as the type that I'm using for the header. Did you see this? This type is our old friend, the HTTP servlet request. But dum, dum, dum. We've changed the package, okay? Now, this may seem like a small deal. It's not that big a deal if you think about it, but it's actually a huge deal. This took years and years of work. Do any of you remember some time ago, I don't even remember when, it was like 5, 6 years ago, Oracle just stopped answering emails. Do you remember this? There was a time about 5, 6 years ago when Oracle just stopped responding to emails for Java EE. And eventually, after about, I don't know, was it 6 months, a year? It was just a long time. Eventually, they came back to the table, and they open sourced Java EE. But they have one requirement. They said, in order to make this open source and to donate it to the Eclipse Foundation, all new changes to these types need to be in a new package, right? And that means that any changes, adding a new type, changing a method, deleting a method, deleting a type, all that has to be in a new package. So this is a political problem, not a technical one, but we have to pay a technical price. This meant that the Spring team worked with the community for years. This took a long time. We had to move Spring Boot 3 to these new Jakarta EE types and make everything work and wait for the community. We also are the lead contributors to Apache Tomcat, so we have to make that work as well. This took a lot of effort to make it so that this works, but it should not be that big a deal because from a technical perspective, the Eclipse Foundation has done an amazing, amazing job. From a technical perspective, oh yeah, look at that, look at that. Thank you. From a technical perspective, from a technical perspective, they've done everything to make this as easy as possible. They gave us Jakarta EE 8, which was exactly the same as Java EE 7, just new license and new documentation and new tests, right, the TCK, because that wasn't open source, so they had to recreate it. That was great, okay, already easy to move. Then they gave us Jakarta EE 9, which is exactly the same as 8, except they changed the package. So nothing else is broken or different, it's just the package. So in order to move to that version, you just do the most insane find and replace ever, right? It's just a lot of find and replace. It's very easy to move. You can do grep, right? So they did a great job. So now, here we are, finally. We have Jakarta EE 10, and this means that as a community, we can all move a lot faster going forward in the future. This is a good deal, but there is some pain, okay? It's not going to be that hard. I think most tools have support for migrating to the new types. It should be pretty easy, but don't be surprised when you see that. That's a new baseline in Spring Framework 6. Everything works, right? That's a nice feature that, again, you may not even notice it. But if you do, don't be too worried. It's easy to move, okay? Okay, so this is our error handler. This is very good. I want to make my code more ready for production. I cannot tell if I am winning if I don't know when I am losing, right? In order to know when I'm losing, I need observability. Observability helps me to understand when something has gone wrong. And there are two ways to do observability, right? There are metrics and there's tracing. Metrics are statistics, things like how many requests you have and how many customers are logged in and how many people have checked out from the shopping cart. And then there's distributed tracing, which shows you the details for an individual request in the system. In the old world, in Spring Boot 2 and in Spring Framework 5, we had Micrometer. Now, Micrometer is a metrics tool that we created more than 5 years ago, right? There's Micrometer, and then Spring Boot depends on this, and Spring Cloud depends on that, and Spring Cloud Sleuth depends on this, and and then, of course, we have Spring Framework, actually. So this is tracing in the old world, and this is metrics. You see the problem here? If you want to do distributed tracing, then you create a circular dependency if you try to use this at any lower level. So it was very awkward. You could do metrics at every level above metrics, but you couldn't do tracing any lower, right? So in Spring Framework 6, this is gone, and now Micrometer also does tracing, okay? So it's much easier to understand and work with, and this means that we have now a new unified API that you can use. You can use the annotations, of course. You can use timed and these sorts of things, right? But you also can use this nice API. So here I'm going to say, just by name. I'll just call it by name. And in order to make that work, I'm going to inject a observation registry. Observation registry, okay? Here we go. And we'll just add that here, observation registry. Good, this.registry equals registry, voila, okay? We'll say registry, and then we're going to observe, using this supplier, we're going to observe the results. So we'll say service.byname, passing in the name, okay? Very good, very simple, very straightforward. What this does is it creates a context. It's going to create the metric called by name, but it's also going to create a context. If you are making a request to another service, that will be traced within this, as long as you have set up tracing in your system using, for example, a tracing system like OpenZipkin or OpenTelemetry or something like that. So in order to see all of this, you need to enable your actuator endpoints. So I'm going to use all the actuator endpoints. I'm going to show the health details always. I'm going to set up the Kubernetes probes, okay? Just a few things that you get for free by using the Spring Boot actuator. And then we can go to the actuator and we can see things like the health, right? You've got liveness and readiness probes. This is all old, but it's interesting. And then we have, like I say, the metrics. These metrics show you information about the system. Let's make a request to this endpoint. I'm going to refresh this a number of times. OK, good. And then refresh, and you can see it says by name equals this, OK? And I can see that I made 49 requests. The total time was this long, and so on. So all of this I could send to a time series database like Prometheus or Atlas or whatever you want, right? That's easy enough to do. Also, you can send it to a tracing system like Zipkin or OpenTelemetry or whatever. So, my friends, we have an application that is observable. We've looked at the new unified observable API. We looked at problem handling and all that. I think it's now time to talk about getting this thing into production. And this is where things get really interesting for me, is because I want to take this thing to production. And obviously, there's a few things that you have to care about when you work with production. One is, how do you get a container out of it? Well, obviously, you can use build packs. This is not a new thing. This is old. But you can use this to take any application artifact, if it's a java.jar or a Ruby on Rails or a node.js or a Python app or a Vue or React or Angular or a Perl application or a P-hey-hey-hey. P-hey-hey-hey-hey. P-hey-hey-hey. I can't do it. It's not a language. I refuse. Anyway, you can take any language and any technology and turn it into a container using build packs. There's even support in Spring Boot. So you can go here, and you can say, Gradle build boot image, OK? That's easy enough to do, right? I don't want to sit here and wait like 40 seconds for that to finish, because this is old, and you've seen this before. That's just one thing you should know about. That's a very useful way to get a container. The other thing I want to do is to make my application as efficient and small as possible, OK? And here, my friends, it's worth remembering that Java is actually a very efficient, powerful language, right? And if you look at this old graph from 5 years ago that looks at programming languages that use the least electricity, there's some very interesting information here, right? This is a normalized table of results for energy, time, and memory. So, of course, C is the best. It's the least memory and the least energy to run some code. Rust does pretty good. C++ does pretty good. Ada, but who cares? Like, I don't... am I missing something? Are people using Ada right now? Are you using Ada? You were using Ada 2 days ago? That's not the same. But why? What? Oh, OK. Right. So, OK. Anyway, great. There's Ada out there in the world to be maintained. And then there's Java. And Java, you can say, is 2 times as inefficient. It's worse, 2 times worse than C. Not good, but also it could be way worse. For example, here's C#, here's JavaScript, TypeScript, wow, right? And then you've got this thing right here. And then you've got Python, right? This is 35 times or 33 times more inefficient than Java. And it's a very good language. I'm not saying there's anything wrong with that. I'm just saying we should all remember Java is very, very good. It's an amazing, amazing runtime. And there are a few things that make it amazing. One is the garbage collector, right? The garbage collector does amazing work for us for free. It's a miracle of modern engineering. I will say, however, that there is a product manager who works at a company in New York, in the States, who has the claim to be the original Java garbage collector, right? This is This is that engineer, product manager. Her name is Jesselyn, and she is from the island of Java, Indonesia, and she is the Java garbage collector. It's true. Now, this is also from 2018. It's one of my favorite tweets ever. And look, here's why. Look, there's almost 20,000 people that get the Java garbage collection joke and are on Twitter and care about like the country and the place of Indonesia. That intersection, that's all 20,000 people right there. That's awesome, right? Good. So that's the first thing. I just want to correct the Java programming language, right? It was not the first, obviously. The other reason that Java is so amazing, the runtime, the other reason that Java, the runtime is so amazing is because it has a just-in-time compiler. And this just-in-time compiler does amazing things for us, right? It can do amazing things when it can find code that doesn't do anything fun, right? So if you do anything fun with Java, like proxies or reflection or serialization or anything dynamic that makes Java different from C, then it doesn't work. But if you do something where it's just able to look at the code and understand what it is doing very clearly, then it will turn that code into native operating system and architecture-specific code. And it does a great job. Large organizations like Google and Alibaba and others, they warm up the service. They actually put the service in production, direct traffic to get it warm, and then they turn on the full traffic, right? Because the just-in-time compiler needs to kick in. So the question is, okay, the just-in-time compiler does not like fun, it hates fun, but it's really cool. So what if we could somehow account for the fun, all the dynamic stuff, and then use it for our whole program? Well, that's the goal of the GraalVM AOT native image compiler, okay? And the GraalVM native image compiler requires configuration files, lots of configuration files. And so we think, as a framework, Spring is in a very good place to generate that configuration for you. And so that's a big feature in Spring Boot 3.0 and in Spring Framework 6.0 is this new AOT GraalVM native image support, okay? So I'm going to go ahead and kick off a native compilation. The problem here, my friends, is that this compilation takes a while, okay? And now I finally understand this cartoon. Do you remember this cartoon? I didn't understand this joke before. I'm new, right? My code always compiles quickly before. Now I get it. Why are you slacking off? Your code is compiling. Oh, okay, because they were using GraalVM. Now, I guess, I don't know. Anyway, to me, this is the GraalVM compilation is actually pretty frustrating because it takes like long enough that I get kicked out of the zone. I'm no longer in the flow, you know, and that makes me sad. But it's also not long enough that I can do anything useful. I can't go to the bathroom. I can't like check emails. I can't take a walk or make a cup of coffee. So I'm just sitting there waiting and waiting and waiting. And it just makes me very frustrated because I start to hear elevator music in my head. Do you ever hear elevator music when you're just, or like the music from Jeopardy, you know? And I start to hear it, and it got me thinking, gosh, it would be really nice if everyone else heard elevator music too. So I went to the Oracle GraalVM project and I said, would you please play elevator music during the native image compilation process? And then I said, I already hear elevator music in my head while I do these sometimes long-running compilations. I just like everybody else to hear it too. And then I said, thank you in advance, and I appreciate your amazing work. And I do. They do amazing things. It's really good technology. And people were, I think, amused. And our friends over at Red Hat, they left a link here to some, does anybody here remember the James Bond movie GoldenEye from the 90s? There's a soundtrack. I forgot this. There's a soundtrack where they have elevator music. It's actually pretty good. I'm not going to play it here, but you can find this issue and play it on your laptop, right? And so that was a good idea. And then somebody else said, hey, maybe we could have beeps, you know? And that makes a lot of sense. Even my toaster will give me a ding beep, it'll tell me when it's done, right? Why can't my compiler do that? That also makes a lot of sense. And then this gentleman, a gentleman named Fabio Niephaus, he's a researcher on the GraalVM team at Oracle Labs, okay? And he's a doctor. And he said, thank you for your feature request, Josh. The problem with playing music during the compilation process is that it's just fixing the symptoms, and we've been and are still working on the cause, making GraalVM-native images more efficient in terms of time, memory, and CPU consumption. He continues, anyway, I have prototyped He continues, I have prototyped a Josh Long mode, but for some reason, he continues, I have the feeling my PR will be rejected, probably because of copyrighted music. And that, that's a concern, I guess. So this is what that would have looked like. This is the future that could have been. So you would say native image, -- Josh Long mode, hello world, and you would get this, right? And it would say music brought to you by Josh Long. And then it would have, it would have me, right? Which, that could have been good. I think, don't you want that? Am I the only one? That'd be so cool. So anyway, he continues, on a more serious note, yes, we could add a -- ring bell when done option that prints the bell code after the compilation process. So, I think our build's probably done now. So let's go here. And yeah, you can see it took about a minute, like a long time, right? Not good. Native compile, and then we're going to run that. Oh, we have the port running already. We have the process running. Oops. Here we go. And there we go. Good, look at that. So there's our application, our 4 records in a tenth of a second. Really good, really fast. Good for serverless if you do that, but I don't really care about the startup. What I care about is memory, right? So here's the process identifier, right? I'm going to go here, ps-o RSS, and I'll paste that. That'll give me the memory of that application. Oh, that's nice. 100 megabytes for an embedded web server, application, database layer, etc. Of RAM. How much memory does your application take in production? Just raise your hand if it's more than 100 megabytes. Yeah, I mean, the rest of you are lying. It doesn't matter what you're doing on Java, it takes more than 100 megabytes. On the other direction, how many of you have ever seen Slack take less than 100 megabytes? I mean, I haven't, but it's possible. Okay, good. So this is like a fifth of a Slack, right, or something like that. It's very, very good to have that. And 20 years ago, I went into a data center, and I plugged in some. Did anybody here go to a data center before? I don't mean like the AWS console page. I mean like an actual data center, right? I went to a data center with a jacket on because it's freezing, and I took a patch cable and I plugged it into all the servers in our rack. A rack is the cage and the shelf where you keep the computers. And I plugged in the serial cable into these computers, and I remember looking at the memory, and I thought, gosh, it's taking 2 gigabytes of RAM to run this application. And the reason it was 2 gigabytes was because back then, in 2003, we were using 32-bit Java and 32-bit operating systems. Right? Things are better now. We have 64-bit. And so back then, we wanted to have more gigabytes of RAM because we had application servers, although most of the time it was just one app inside the application server, right? But we wanted to have more, but we couldn't. The garbage collector couldn't keep up. But now, here we are 20 years later, and it's 1/20th of the size. That's a good deal. That's very good situation to be in. If you had told me then that in 20 years we'll be doing this, I would have laughed. Oh well. So we have a service. I want to build a client now. And here, friends, this is just pretty straightforward stuff. I want to build a client that talks to the service. So I'll use the reactive web support. I'll use GraalVM. I'll use the Spring Cloud Gateway, maybe. I'll use GraphQL. Just a few things that we can use to talk to that service that we just created. We'll open this up in our IDE, cd downloads UAO client.zip. Here we are. And client application. here we go. So the first thing, I want to build a client. I could write actual code. I could say, customer client, and I could write a method that returns a reactive stream of my customers. I need that type, by the way. I need the type called customer. So I'm going to do something terrible, something that you should never, ever do, ever. Not even when you're all by yourself at home and no one is looking. I'm going to copy and paste code. So here we go. We'll take that. I'm going to paste that there. I'm going to build. I could do this. I could, it's not hard to see what I would do here. But this looks suspiciously like work, and I don't like work. And so in Spring Framework 6, we have a new feature that lets you create. We had similar things in other projects in Spring Cloud, but now it's part of the framework, and it's generic, and it works in the same way, whether you're doing reactive or HTTP or RSocket or whatever. So here, I'm going to create a customer client, okay? And it's going to provide an interface called, like this. And I'll create another endpoint here, another method for the name, string name. Now, this is an interface, but I need to tell Spring how to map these names to endpoints on the service. And I can use a new annotation, get exchange. This is the client side of get mapping, okay? So I'll say customers, and then we'll say customers name, okay? Very, very simple. Here we are, path variable. This one we can share. Now I'm going to turn this interface into a bean, into an actual bean definition. That's easy enough to do. I can just do this once. Most of this work you can put in a single place and then reuse the definition, but I'm just going to do it all in once. Okay, so client adapter, web client adapter dot for client. I'm going to inject a reactive web client builder. Okay, builder dot base URL, like this. Base URL is HTTP localhost 8080. Okay, and then build, right? And then build dot create client for the custom client. So again, you can reuse all of that except for this last line. For all the other beans, you can store that as you store the byproduct of this as its own little thing and then reuse it. But okay, you get the idea. So we've got this customer client, and I'm going to inject that into a bean here. Here we are. Return new application runner. Okay, and then we're going to inject that here. We'll say customer client cc.all.subscribe. And we'll just print out the results that arrive. System out print line, very good. Okay, we start, and this is going to start up on a different port 9999. Oop, 9. Okay, run. Why don't IntelliJ? Good. Whew, quelle chaleur. Is somebody compiling Scala? What's going on? It is very warm in here. Okay, so we have our data. Look at that. We built a declarative interface-based client using this interface. That's great. That's a nice way to connect my client to that service. Another thing I might want to do is to use a gateway. And of course, this is not new, so I won't spend too much time on this. But you can use Spring Cloud Gateway. So you create a bean. You say route locator gateway like this. Route locator. Whoop. Okay. Builder RLB. And you say rlb.routes.route rs.path. Yeah? Yeah, thank you. Root. Yep. So I'm going to send this. I'm going to send this request that arrives on port 9999 at this path. I'm going to forward it. I'm going to proxy it to this service over there. Pretty simple. And the power, of course, is I can use filters. So the filters, I can change things. I can use filters to change the path, for example. I could do retries. I could add response headers to do cores, for example, something like that, right? I could do security. I could do all sorts of things with these filters. And this is one of the powerful parts of Spring Cloud Gateway, okay? So let's go ahead and restart that. Now, that's fine. It's useful if you have back-end services and you want to expose all the data in a consistent, unified way. But the problem is, you should be driving your services, you should change the services in response to the requirements of the clients that need and use them, right? And so this becomes a problem because every time there's a new client, you have to change the back end. And this, you create a dynamic where the clients are waiting for the back-end developers to give them a new view of the data. This is a problem that Facebook had back in 2012, right? And so they wanted it so that clients could get access to the data that they want, as little or as much of the data, and put it in the shape that they want without having to make 10 different calls to 10 different services. Imagine you're driving through the desert, and you've got 2G, and you're on Android, and you've got 3% power, right? And you're lost, and you need your phone to get you out of it. Do you want to make 10 different calls to 10 different network services, or would you like one call with all the data to come back immediately? And so to support that use case, they created GraphQL, okay? GraphQL is really nice. You can actually easily describe your services like this. So I can create a new schema here, schema.graphqls, and I can say type, query, and in GraphQL, you describe the types in your system like that. So I've got a string for a customer and an ID, and I'm going to describe a field. This is a field that returns bracket, bracket. That's an array of customers, okay? Now, I have to implement that schema. So I do that over here. I say @controller, class, customer, GraphQL, controller, and I'll inject my new client that we just created there. We'll just inject that into the controller. And I'm going to use query mapping, okay? So the query mapping is actually, I'm going to map this controller handler method to that field in the schema, right? So it's called customers, and it returns more than one customer. We've got customers, and it returns more than one customers, and it's using a query mapping, and this is the well-known type called query, okay? So it's a controller, just like a regular REST or HTTP controller or whatever, okay? Now, what if I wanted to interact with that? Well, of course, I can add graphical here, a nice client that you can enable in your service. We'll go ahead and restart it. Localhost 9999 graphical, okay? Now here, I can say I want customer ID, okay, no problem. I want the name as well, no problem. But what if I wanted to introduce a new field? Well, GraphQL makes it easy to add new data to the response that doesn't exist in the underlying services. So let's imagine, for now, just for time, that I have a microservice that has profile data, you know, the username, password, that kind of stuff, right? I could add this to the schema for the customer. I could say, okay, there's a type called profile, and there's a new type here called profile that has an ID, and I want to add that profile data to the customer, even though the backend microservice doesn't have that arrangement, right? Well, here I will use schema mapping. So customer, profile, profile, customer, customer. So I'm actually resolving the profile with the root aggregate type, the customer, injected there, okay? Now the problem, of course, is here, I'm creating an object in memory, in place, sur place, right? But what if I was making a network call? If I called 10 different services, then you'd have n+1, right? And that's very inefficient. So let's say I go here. I want the, refresh, okay? And I go here, control space. Look at that, I get schema, isn't that nice? ID, hit response. Okay, great, but now it's very inefficient. I'm doing n+1. So instead of doing n+1, you can do batch mapping, right? And again, I don't have to change the schema at all to support this. Spring for GraphQL gives you this very efficient approach to building services that lets you hide the construction of the backend services from the clients. They don't need to care about how this is done. So you can imagine making a call, a network call to a service that gives you access to all the data for those customers, okay? So for var c customer list, map.put c new profile, c.id, return map, okay? So this will get called instead of this. We can restart it. And again, you know, the same, compiling. Okay, there you go. Same thing. Now, friends, we've only looked a little bit. We only covered a few things. Obviously, there's a lot more we could talk about, but I think we're just about out of time. Makes me sad. Who learned something new here today? Good. Who had fun? Okay, very good. I appreciate you, my friends. Remember, we talked about Spring Framework 6, Spring Boot 3, all the new features, the new baselines, Jakarta EE, Java 17 and better. We looked at the native image support. We looked at the declarative client support. We looked at all the new error observability support. We looked at a lot of things here, my friends. The new GraphQL support. I hope you got something out of it. Merci. Merci beaucoup. Merci mille fois.